Okay, in this chapter, we'll learn about the area of a triangle formula now note that this is using the sine function. So let's just start with something that we should already know, which is a right angled triangle. Okay, and let's say if this side is 8, that is 10, then the area, right, would be half times 8 times 10, right? The two half of the product of the two sides, so that'll just be 40 whatever square units. Now note that this would work for any right angled triangle, but what if we have a triangle that looks like this, where the 10 length side is here and then the 8 length side is here. Now we know that this angle is, let's say, 40 degrees. What's the area of this triangle? Okay, well, let's put it this way. So it's not exact, it doesn't really look right angle to me. So let's say this is not a right angle triangle. How do we calculate the area of this scalene triangle? So that's why we need to know the sine rule for the area. So or the area rule of the triangle. So that's half of, looks very similar, it's half of the products of the two sides, but you need to multiply that by sine of the included angle, 40 degrees. Okay, so when you actually punch that into the calculator, you will get the area for this triangle here. Now let's go back to the right angled triangle and see whether this formula actually applies. So let's say there will be 1/2 times by 8 times by 10 times by sine of the included angle, which is 90 degrees. If you try to punch sine 90 into the calculator, you would get this equals to 1. So that's why for a right angled triangle, it's just simply half of the product of the two sides next to the right angle. Okay, so the main area rule is if you have any triangle, and let's say if you have the two sides AB and the included angle C, then the area would be equals to half times the product of the two sides and sine of the included angle C. Alright, so that's the area rule. Let's look at some examples now. Right, let's have a look at example 18 here. So we've got the two sides, 9 and 15, and then the included angle, which is 42 degrees. So simply the area would just be half times 9 times by, I like to write in brackets, half times 9 times 15 times by sine of the included angle, 42 degrees. Alright, punch that into the calculator, and you should get roughly 45.2 centimeters squared to 1 decimal places. Okay, now let's have a look at another example here. We have one side and the included angle, but we don't have any other side. Now we do have the area though. The area is 34 centimeters squared, and we need to find the length of BC. So this one, we actually given the area. So using the area rule, A equals to half AB sine of the included angle C. We'll put in what we know. So the area is 34. So 34 equals to half times it's just a product of the two sides. We can just pick any side, so that'll be 7, and then times by the unknown side BC that we're trying to find, and then sine of the angle 61 degrees. Then the next job is just to isolate the our main variable BC there by bringing everything over to the left hand side. So first 1/2, when you bring that over, it becomes the reciprocal, so that will be 34 times by 2, and bring the 7 over means you would divide by 7 because times by 1/7, and then when you bring sine 61 over, you're also dividing by sine 61, so that would just be divided by sine of 61 degrees here, and that would be equals to BC. Punch this whole thing into the calculator and you should get the answer for BC, which should be 11.11 centimeters to 2 decimal places. And that's how you solve for a side given a certain area. Make sure to redo these two examples before you move on to the exercises in the textbook.